All right, this is section 2.5, the voiceover to the homework. This section, transformation of functions. Make sure you have this printed out for your notes. These are the graphs of some basic functions. The identity, the parabola, square root, cube root, cube, reciprocal function, and absolute value function. This is V-shaped. Just make sure you have those printed out by your side. This is kind of super important too. This is also, I provided you a PDF file with this. It's everything together, transformations. You know, it's telling me here how the minus sign, let me get a pencil, how the minus sign flips it across the graph across the x-axis, all right, upside down, so to speak. The two, you would think the minus would move the parabola, in this case, to the left because it's minus. Actually, it's in the opposite direction. The minus 2 moves it to the right 2 units. This is a vertical shift. Minus actually means move it down. If this was a plus, it would mean move up. And this number here, if it's bigger than 1, it stretches it, makes it taller and thinner. If this value is less than between 0 and 1, it makes it shorter and wider. All right, in this case here, 2 would stretch it. So here again, have this out. But to be quite honest, when I go through these, I'm going to actually perform the transformation. But you've got a calculator. You can actually plug the equation, the function, into your calculator. You'll get a picture of what it looks like and match the picture up with what, one of the 4 choices. It's not like I can say, well, yeah, you can use your calculator for everything, but you can't use it for transformations. I will do it the long way, so to speak, manual way. But realize you've got a calculator. You can actually just calculate it and just match up what your calculator shows you with one of the 4 responses. So have this by your side. All right, let's see how we can do with this. Choose the one alternative that best completes the statement or answers the question. How can the graph of negative 3 times the absolute value of x be obtained from the basic function, the absolute value function? What I'm going to zero in on is this minus sign right here. All right, that minus sign does not go with the 3. It's separate. It's a separate action. All right, the 3 is going to stretch it vertically. All right, make it narrower, taller, and narrower. But I want to focus in on the minus sign. The minus sign flips the graph across the x-axis. All right, so I see it here in letter A, and I see the x-axis here flipping it across the x. So I know it can't be B or D because it says y-axis. No, the minus sign flips it across the x-axis. So already I kind of figured out that it's only 2 that it can be. Now, what does a 3 do? It stretches it vertically by multiplying it by 3. All right, it stretches it vertically by multiplying the y-coordinate by 3. Now, what does this one say? This says negative 3. No, the negative is separate. The negative flipped it across the x-axis. The 3 tells me, all right, the minus has nothing to do with the 3. The 3 tells me that it's going to stretch it vertically by a factor of 3. All right, so it can't be C. So, I'm kind of like at A. There it is. It's the process of elimination. I like that minus sign because that usually takes out 2 of the possible answers. Once again, I see this minus sign. This flips this graph across the x-axis. So I see it here, I see it there, and I see it there. So this says y-axis, so I know it can't be letter D. All right. The positive 10. The positive 10, you would think, would shift this curve in the positive direction to the right. It flips it. It actually moves it to the left. It doesn't move it negative 10. It moves it 10 units. All right, so not A, but B. All right, it shifts it 10 units to the left. You would think it'd go to the right, but it's in the opposite direction, and it's reflecting across the x-axis. So we've got the right answer here, the letter B. And what was wrong with this? It said go 10 units to the right. No, the positive 10 would move it to the left. All right, to the left, not to the right. So B was the correct answer. Number 3. Here again, I'm focusing in on the minus. Where am I here? I'm focusing in on that minus sign, which is going to flip this graph across the x-axis, number 3. All right, across the x-axis. I see x-axis here, I see x-axis there, I see it there. So A, B, and C are still in the running. All right. What about the factor of the number 4 here? Number 4. Well, the 4 is going to stretch it vertically by a factor of 4. This says by a factor of 4, and this says 1/4. Well, it can't be that. So looks like A and B are already in the running. And how do they differ? The positive 7 is a vertical change. Takes the whole graph, and since it's positive, it's going to shift it vertically 7 units. So what was this one? This says something about 7 units to the right. No, this is up. All right, if this were a negative, it shifted down. So number 3, letter A. I don't know how we got this 7 going to the right now. That 7 is not contained inside of the radical sign. It's a vertical change. If it's positive, it goes up. If it's negative, it goes down. All right, letter A. Number 4. There's no minus sign to contend with. I want to zero in on this minus 5. That tells me to take my graph and shift it downward 5 units. Minus is exactly, if it's a minus, it's going down. If it's positive, it's going up. This is the opposite. Minus would not go to the left, it would go to the right. This is exactly what it means. If it's minus, it's coming down. So 5 units down, number 4. 5 units down. So this says 5 units up. Can't be that one. This says 1 unit. I don't know where that's coming from. So C and D are in the running. Now, what's wrong with one of these? What? This negative 1 here, all right, you would think negative would shift the graph in a negative direction on the x-axis to the left. It actually shifts it in the opposite way. It goes to the right, so can't be C, it's letter D. Number 5, here again I'm focusing in on this minus sign here, which flips it across the x-axis. So I got x-axis here, x-axis there, x-axis. This says y-axis, so it can't be that. The 3 tells me it's going to stretch vertically by a factor of 3. This says a factor of 2. This says the 3 I'm looking for. This says negative 3. No, already I know it's going to be letter B because the other 2 were incorrect. It's not. The minus sign is separate from the 3. The minus sign says to flip it. The 3 tells you how much you're stretching it by. All right, they're not together. All right, letter B, number 5. Process of elimination. Alright, what am I zeroing in on here? Number 6. Well, first is positive 4.3. It's going to shift it vertically 4.3 units upward. There's upward here, upward there, and this one here shifted down. I don't know what this guy's talking about. Alright, so A, B, and C are in the running. What do I know here? The 0.5. Well, it's going to shrink it by a factor of, because it's less than 1, it's going to shrink it, not stretch it, by a factor of 0.5. This says 0.5, this says 5, and this says 0.04. I don't know where they're getting these two, because this number here is 0.5. There it is right there. I'm all done. 6A, moving on. Alright, what do we got here? I want to focus in first this negative 10, which is going to shift the graph 10 units downward. 10 units downward. So, number 7, 10 units downward, okay. This says 10 units up, can't be that. 10 units downward, C's in the running, shift 10 units downward. 10 units downward, so A, C, and D are in the running. So what do I know here? A positive 6 will move the graph horizontally, not in the positive direction, but in the negative direction, to the left. All right, to the left. So this has to the left. This has it going to the right, so it can't be that. And letter D. So A and D are in the running. Now, how do they differ? All right, the 1/2 is going to shrink it by a factor of 1/2. All right, this says shrink it by a factor of 2. No. There it is there by a factor of 1/2. If I can turn this so you don't get dizzy. Alright, letter D. So those are those. Well, I take that back. We got one more, number 8. Here again, I'm focusing in the minus sign, which is going to flip it across the x-axis. Alright, so those have it. Number 8, so A and D are out of, A and C are out of the running because of the fact they got they got this reflecting across the y-axis. No, it's the x-axis, so it's A, B, or D. Now, how do they differ? The minus 8, you would think it would go to the left, but actually it goes to the right. So this is right. Letter D has this -8 shifting it to the left. No, the -8 means it goes to the right 8 units. Alright, so to the right, not to the left. So we kind of zero in on number 8 as being letter B. You know, something else you could conceivably do. If you're undecided, just take this, you know, this negative x minus 8 quantity squared plus 5, just graph it. You'll know what happened from the original curve. You know what the original parabola looks like. Alright. But here again, I zero in on a couple of things. I zero in on that minus, which usually alleviates a couple of answers. Then I kind of zero in if there's a number here. It's this case here, the graph is going up units. I kind of zero in, and then I take a look at. Usually looking at that and that will allow me to discount, so to speak, 2 out of the 4 answers, and then I work with the other 2 to find which one is the actual answer. Alright, here's what I'm saying here with these remaining ones, at least number 9 through. You can put this, what he's asking me here is to graph that, and then he gives me, you know, 4 possibilities. So what I'm saying here is, what you can do is, just put this into your calculator, graph it, look at the picture on your calculator it gives you, and then match it up with, you know, one of the 4 answers. But I'm going to do it manually, alright? So the parabola, alright, it's a square, alright? This is a basic function. The root function, so to speak, is a square function, which is a parabola. If you look at your basic graphs, that's what the basic parabola looks like. Alright, so the minus 6. The minus 6 is a vertical change. If it's minus, you go down, and if it's positive, you go up, unlike when it's inside the parenthesis. So I'm going to take this graph and move it down 6 units. It's a rough sketch of it. And now take this picture and match it up with, yeah. It ain't that there. That's the absolute value. This is a parabola, but it went up 6 units. My picture looks just like, well, here it is, coming down 6 units. Here it is, letter B. Here again, I could have graphed that, but that was an easy one to perform the transformation. The basic function here is the absolute value function. It's a V-shaped function. Alright. The parabola is curved, so to speak, but the absolute value is V-shaped. So what's happening? Alright, the minus 2 is inside of the absolute value. So what happens to the x happens. So a minus 2, you would think it would take this guy and move it to the left 2 because of the minus. No, it's just the opposite. It takes this guy and moves it to the right 2 units. Alright, so the vertex that was at the origin now is moved 2 units to the right. And if I can sketch this properly, that's what we're looking at. Number 10, and this is, you know, how are we getting these from? How are we getting that? Just flipped across the x-axis, I mean, duh. There it is, letter B here. Again, you could have graphed that real easy. Number 11, what do we got? Here again, we got the basic absolute value. I've got a minus sign, so here's my basic absolute value function. It's V-shaped. Because of the minus sign, this flips across the x-axis. Alright. And then the 4 would stretch it out. Alright, it would stretch it out, it would become narrower. Alright, stretch it out. So I'm looking for what that looks like, and you would think for a second it's this guy, but this is a parabola. You see how it's curved here? This is what I'm looking for right down here, right? See the V-shaped? And there's my attempt at it. I could have drawn it maybe a little straighter. Alright, letter D, number 11, letter D. That's a parabola. This is the V-shaped here. You're starting out with a basic absolute value V-shaped function. Alright, number 12. The basic function is your parabola. It's a square. So it looks like this. And a couple of things. Let's see. The minus 3 is inside of the parenthesis. So you'd think it would take this guy and move it to the left readers, because of the minus, no, it moves it just the opposite way. Alright, moves it to the right 3. And then the minus 4 takes this guy and moves it down 4 units. Alright, so that's what I end up looking for, the vertex right down there at positive 2, negative 4. Positive 2, negative 4 for number 12. Right here. Positive 2, negative 4. Letter D. I don't know where that's coming from. That looks close, but it went over, instead of going over 3 units, it went over 1, 2, 3. You went over 4 units, then came down to, you want to go over 3 units, 1, 2, 3, and then come down 4. That's why it's D versus letter A. Number 13. Once again, let's see, it's a basic parabola. The minus sign here is separate from the 1/2. It flips it across the x-axis. The 1/2 stretches it. Alright, it gets narrower. And let's see, the positive 3 would move this 3 units to the, you would think it would move it to the right, but it actually moves it to the left. The positive goes in the opposite direction. And then the plus 2 takes this guy and moves it up 2. So I'm looking for something with a vertex in the third quadrant here. Now you're thinking, which one is it? Is it letter A, which looks very similar to letter C, number 13, and it's the 1/2 here. I made a mistake. The 1/2, because this is less than 1, it's making it, didn't make it narrower. It should have made it, let's see, it got flipped. And then a 1/2, the 1/2 would kind of made it fatter. Alright, made it fatter. If this were a whole number, it would make it thinner. So making it chubbier, so to speak. This is why it's the letter C. But once again, if there's any doubt, put that into your calculator. We knew it wasn't him, and we knew it wasn't him. Here's another way, a really slick way of looking at this. Do you see this? I was trying to think of finding the y-intercept. F of x. F of x is the same thing as y equals negative 1/2 x plus 3 quantity squared. And I'm thinking of plus 2. I'm thinking of putting in 0 here. 0 plus 3 would be 3. 3 squared would be 9. Half of 9 would be a negative 4.5 plus 2 more. My y-intercept is negative 2.5. Here I've got a y-intercept. Here I've got a y-intercept here. It looks like something smaller than 10. But do you see the y-intercept here? Alright. The y-intercept here, about a negative 2.5. That's how another way I could figure out it's letter C versus letter A. Or here again, I could have just put this into my calculator and graphed the thing. That one is probably the trickiest one we've seen. 14, the basic function is absolute value. So it's V-shaped. The 1/2 is going to make it fatter. It's going to compress it, so to speak, make it wider. The +5 does not move it to the right, it moves it to the left. And then the -4 brings it down 4 units. So something down here. Alright, the only thing that even looks like this at all, my picture, is, well, I take that back. There are a couple that kind of look like this, but it's letters, number 14 is letter C. And once again, what I could have done, here you got a y-intercept, looks like 6. Here you've got a y-intercept that's negative. So let me take this guy here and h of x, I want to say that y is equal to 1/2. In place of x, I'm going to put in 0. 0 plus 5 minus 4. So I've got 1/2 of 5 minus 4. So this is what, 2.5 minus 4, or minus 2.5 for a y-intercept. Alright. 0 plus 5 is 5. 1/2 of 5 is 2.5. Minus 4. No, minus 4 would be 1.5. Negative 1.5. 1.5. And if you look at this y-intercept here, you can see it's negative 1.5. Another way of determining y was letter C versus letter D. They look similar, but notice how this guy was is sort of compressed, so to speak. When this value out in front is less than 1, between 0 and 1, anything bigger, it stretches it, makes it taller and narrower. The 1/2 makes it shorter, so to speak, and wider. It compresses it. So another reason it was letter C, not D. But, you know, figuring out the y-intercept here, you know, zero it in on number letter C. Here again, you could have graphed it on your calculator, and you could even use tables to find your y-intercept. The cube root function, the cube function, excuse me, the cube root. So the basic cube root looks like this. And what's happening is it's x plus 2. Now notice the 2 is inside of the parenthesis. What's happening to the x is happening to the 2. Positive 2, you'd think it would move it 2 units to the right. It actually moves it 2 units to the left. And if I draw this again, that's what it looks like. Alright, so 15 is letter A. It kind of flattens out there, but this is the only one that went 2 units to the left. I don't know what happened here. This is not even a cube root, that's a parabola. Letter A. It is one that you could have very easily put this into your graphing calculator, and then this would be the picture you would get back. You wouldn't have to do anything else. The cube function. The cube function looks like this. Alright, so what's happening? I'm just taking this guy and I'm adding 4, which means, you know, the 4 is not inside the cube root. This is a vertical shift. If it's positive, it goes up, and if it's negative, it comes down, unlike when the things are contained inside. So I'm taking this guy and I'm just moving it up 4 units. 1, 2, 3, 4, and I'm kind of like I'm actually missing it. Obviously, I'm not an artist, but the only thing that even looks like vaguely like my graph here is letter B. And once again, to avoid any kind of confusion, you could have put this into your calculator very easily. Alright, I can kind of show you if you have a question on how you get to the cube root. Something that I could do on a Zoom meeting, or if you have a real difficulty, I can actually do a video how to do the cube root. Keep that in mind, number 16. I can't tell if you're watching these because sometimes there's questions that have been asked to me over and over, and if you don't ask it, I'm saying, well, kind of funny. To ask a question, obviously, you had to have done the problem. Alright, so we got the cube function again, not the cube root, but the cube function, which looks like this. The minus 7 is going to take this, instead of moving it to the left because of the minus, it moves it to the right 7 units. So something like that. And then the minus 1 takes this guy and moves it down 1, so to speak. So we're looking at coming down just slightly. And the only one that looks kind of like that is, oh, where are we? Number 17, yeah, letter B. Alright, this guy went up 1, this guy came down 1, so there I am. This guy went to the left instead of going to the right, same thing, went to the wrong direction. Alright, the minus you would think goes left, but no, it's just in the opposite. This is exactly, minus means down, positive means up. Minus means you move to the right, positive means you move to the left. That's why it's letter B. Alright, the remaining ones I'll take care of in another section.